Brian, Eliza, Greg, Dave, and Andrew.
Like the Musketeers are like this, right? It's like a Mickey Mouse Club. Making a boomer reference there.
No, there's the I had to suffer through some Mickey Mouse Club with the younger one.
Have they rebooted the Mickey Mouse Club?
Yes.
I mean, what am I doing? What am I doing to myself? What am I doing to myself? It's like, really? They turned that superhero comic from my youth into a movie? That was surprising.
Yeah, it turns out Mickey Mouse, still a valuable IP. Like, who knew?
That's right. Of course, I shouldn't be surprised. This is great. Oh man, I'm stoked.
Don't you take this away from me. I'm more stoked. Okay, I
have
had this on the list.
You know what? You can Leventhal me right now. Go ahead.
You know how long I've had this on the list? Because we have a document of proposed topics. Do you want to guess how many months this has been on the list?
Our audience is like, yeah, show us or get the fuck out. No way.
Oh, I'll show.
No way. You guys have.
I'll show the version history.
Yeah. No, but it's true. It's true. We have tried some modicum of advanced planning at some point in time.
Yeah.
And no, this has been on the list. This has been on the list for a long time.
March 2023. It's been on the list a long time. And I'm very excited that we're here.
I am very excited we're here too. And we call it Leventhaling when you tell me that when I have an idea that you've said like, no, like this is the idea that Adam, have had that you've been shouting down for. But in this case, I don't think it's a Leventhal. I think you're actually right.
I actually think it is a Leventhal. We just have different definitions of what it means.
No, it's like that is a Leventhal because I am right. That's exactly right. That's what makes it a Leventhal. In any case, this has been an episode that has been long overdue, and it's so overdue that I almost wondered if we'd already done it. What do you call that? I guess that's just early onset dementia. But I was
that's right.
I don't think that's got a special name. I also did love that you had this is a bit of a special episode in that you got ahead of what you anticipated to be an objection, and we have a guest appearance from Lur from Futurama has made a guest appearance in our Discord here. Do you want to?
Yes. Well,
give Lur's special disclaimer before we.
Sure. So, special disclaimer. We will talk about Omicron. Omicron is the name of a repo that we use. That's like our mono repo, but not really a mono repo. But it's like our biggest repo, shall we say, for the control plane. We named it Omicron.
It's a portly repo.
It's a right. It is a big mono among many. And it was named. It was a Futurama reference for Lur, who
it is a Futurama reference. It remains a Futurama reference. I say
right. That's right. It is and was a Futurama reference, referring to the Omicronians, the folks from Omicron Persei 8, and a few months after that something else was named Omicron, but we were there first. I hasten to point out.
And it took more than a pandemic for us to change our name.
That's right.
We did not actually, even though there was a moment where people were like, you codenamed your project Tuberculosis? That just feels in poor taste.
I mean, they should change their name. They're the ones who suck.
Exactly. Yes. Excellent Office Space reference. Very good. So that is our special disclaimer. We're going to hear us talk about Omicron. We're not talking about the variant of SARS-CoV-2, although that's now becoming dated, right? That's now just become one variant among many. So now it's not. Mm-hmm. And maybe that's back to being Futurama reference. Pretty great. So on the Saga of Sagas, did you go back and listen to our journal club with Katie McCaffrey?
No, I didn't. I should have. I didn't.
I
went back and
it was amazing.
I read some RFDs, but not that one.
Okay, so just a little bit of context on that, because this was especially important. Oh, also, people are in the chat are wondering if they're mispronouncing Omicron. I'm probably mispronouncing Omicron. Omicron or Omicron, I don't know. It feels like that could go either way. Idempotent, though, is definitely idempotent, right?
Yes.
Okay. That's right. Someone's Andrew's saying it's a conflagration of mispronunciations. Andrew, it takes daily affirmation for me to say conflagration and not what that other thing that I desperately.
What's the word you're saying? Affirmation? I don't think that's right. I'm just
well, Well played, I think. Oh God. Oh, that's well played, right? That's a joke, right? Right? To someone. But so and this was especially important, I think, in the earliest going of the company, where we had a very clean sheet of paper. And on the one hand, it's great to have a clean sheet of paper. It's fun. You got a lot of design latitude. On the other hand, it can be really intimidating and challenging, and you're constantly trying to, you get that always that challenge in engineering where, at what point you kind of stop searching for an existing solution and implement your own and so on. So there were a lot of challenges. One of the things we wanted to be able to do was institute a way for us to kind of evaluate outside work. And Adam, you and I had both experimented with this in a couple of different ways. And one of the things we'd done journal clubs in the past. And I think one of the things that was kind of the undoing of journal clubs, at least certainly at Joyent, was we tried to do this kind of regularity and it just kind of fell down. And so we did this kind of shrink to fit model where if somebody finds a work outside that's interesting and they want to talk about it, and we have an RFD about it that I should make public. I don't think I have made that public. Is that 35? I will make that public if I haven't. On how we do journal club. And we have a very lightweight process to get everyone together to discuss it. And one of the early ones around this was on Katie McCaffrey's work on sagas. And so a couple of things about that. Adam, do you know when that journal club was? The date?
I'm going to guess it's 2020. And I'd go like June 2020, July 2020.
That's a good guess in that, like, you are guessing this is an extremely long time ago. It was actually in very early 2021.
Okay.
Ominously, January 5th, 2021. So a date that
nothing else going on, right?
A date that will live in infamy, infamy -1, and I definitely am never gonna forget that day. I'm definitely gonna remember that date.
Yeah. Infamy adjacent, yeah.
Infamy adjacent. The Broncos played Monday Night Football on September 10th, 2001. I have not forgotten it. So I feel that this is in the same boat. But so January 5th, 2021. So super early. And one of the things that I learned from re-listening to that, and so we record all this stuff, which we've talked about in the past, I think is so important. I think it's something that folks should definitely, recording your conversations is so incredibly valuable. There's this big kind of bathtub curve. Things are, valuable shortly after that recording. Someone is out or something and they can catch up on it. And then there's this kind of, the bathtub of it is that there's this kind of long tail where all of a sudden something spikes up and becomes really interesting. And it became really interesting to me to go back and re-listen to that recently. And Katie can't join us today, but she's gave us her well wishes. She'll catch up on the recording. But listening to Katie, because we had Katie in to discuss her presentation on Distributed Sagas, where she had kind of found this previous work on sagas. And Adam, one of the things I learned from that discussion is you were the one that put us onto this. And do you remember any of the origin of that?
Yeah. So as I recall, so we knew that we wanted Omicron to coordinate activity from a bunch of different services. Like I thought of that as sort of workflows. I don't know. There are probably other terms for that kind of coordination. And where you're talking about lots of different services, and if something went wrong, you wanted to know how to unwind it and get yourself back into some reasonable state. So this notion of transactionality across this distributed system. I had first bumped into Katie's work around distributed sagas when I was doing something much more explicit, not looking at microservices, but in my previous company, we were talking to a bunch of different APIs and looking at what would it look like to create this kind of transactionality across disparate APIs, like an API from Google and Open API and for your calendar software or whatever. And if you wanted to do this kind of composite operation and part of it failed, how would you undo that? So that's how I stumbled onto it. And I never got anywhere with it in the previous company, but it seemed like a good fit for what Dave was thinking about.
For sure. And Dave is a good segue to you. I mean, you were one of our earliest engineers, and you were kind of thinking about this stuff from the outset. And obviously, you and I had worked together at Joyent. So this is not your first control plane. Can you take us through kind of your first explorations of workflows and sagas?
Yeah, so I I I remember this period. It's later than I expected it was. This was like last quarter of 2020, but that's when we started thinking about this, and I remember thinking we're going to have a whole lot of things that need to do these complex operations that touch a bunch of services. And the example we always used was VM provisioning. In
Yeah.
VM provisioning, you've got to do a whole bunch of stuff, but I mean, you could think of simple things like allocate a server, pick a server, allocate resources on the server, tell it to actually go start this thing, but then we also have to program the switch with like routes so that things from the outside can reach that thing. So it's like just a simple example where you've got some database state and you've got two other services that need to be coordinated. And like again, you need to make sure that if you fail to program the switch or something late in the process fails, then you also deallocate the resources, right? And we would also talk about like SSD firmware updates might look like this, VM migration might look like this, replacing a faulty server might look like this. And so we figured it would be a pretty reusable thing. And, traditionally, like probably maybe a long time ago, you would just have straight line code with a bunch of like if error go to out or whatever, undo
Yes.
whatever I've done so far. But then
Yeah.
what if you crash at various points?
And it should be said, like, we lived this, right? I mean, like, whenever I think about this, like, there's a reason we think about the VM provisioning example, because that one is very, at least vivid in my memory of this just long tail of problems, of instances that don't get cleaned up properly, or that are kind of like in this zombie state where they're kind of half created because something failed along the way. And it was not good, I feel. Not that we were doing our best, but it was complicated.
It's a lot, and like I mentioned those three things, but it can get pretty complicated when you talk about like an instance create request could say I also want to create like 3 or 4 disks and attach them, or I want to attach some other disk that already existed. You need to like make sure that you delete the disks that you created, but not the ones that you just wanted to attach, and like there's just a lot of different. It's pretty clear, I think, that you don't want to write ad hoc code to do all that stuff. I think you want to find a way to decompose it into these subproblems where you just have like a simple thing that you like an action is what we ended up calling it, and then something that can undo that and compose these in pieces and stuff like that. And we had done something like this at Joyent, but I remember it always being kind of a pain point, in part because of the language it was written in, and it was pretty limited. Like you had these named things that you could put in order, and it could undo them, but there certainly wasn't a lot of strong typing. There wasn't a lot of like branching and looping and stuff like that. It was very static. And also I think there was a big challenge around the component, like the dependencies between the components. So the workflow would live in one place, but it would call APIs and services that were in some other place. And so you had these flag days every time you changed everything. And I think one of the things I noticed, Adam, I'm not sure what your take on this was, but I feel like when we looked at a lot of the stuff that was already out there for this, a lot of it seemed aimed at solving an organizational problem as much as a technical problem, which is that you have you've got like 100 teams working on 100 services, and the workflow thing winds up being a hub that coordinates everything. It's like the place that you put all the pieces that talk to each other or something like that. And we were really hoping we wouldn't have that problem, at least not for a while. And I think it's fair to say we haven't had that problem yet. We don't have 100 teams yet.
We don't, but I think that's a very good point about in terms of Conway's law expressing itself in these workflow engines. And David, in the chat, I just dropped a link to RFD 107, which was the RFD that you and Adam were writing, exploring different kinds of workflow engines. So I thought that was good. Did you go back and reread this recently? By the way, it's kind of interesting to go back and reread it. It's amazingly prescient, I feel.
I haven't looked at it recently.
It holds up well.
I read it today. I think, as I often am struck by some of these early RFDs, where we investigate lots of potential technologies, it's one of these ones where I'm like, why did we think any of these things was going to work for us? Like, clearly we had to build our own thing. I mean, and obviously it wasn't clear at the time, but that's how I feel about a lot of these early ones. Such optimism about the what's printed on the label and how it's going to work. And
okay, so and Adam, now look, it's been a long time, so you can come clean. Do all of these workflow engines actually exist? Are these real names?
You got me.
In particular, are Uzi and ZB both things? I mean, did you just come?
Oh no, those are real. It's N8N. That was the one that I made up. I snuck that one in. No.
just to see if anyone's. Is this like one of these tests, the brown M&M for RFDs? And you're just like, hey,
no. When I
oh yeah,
spent,
Bryan, you may not remember. You said you read every word of this RFD and you thought it was great. Well, as it turns out, guess what you thought was great? N8N. I made that up.
Yeah, it turns out that was during the pandemic. I didn't have any childcare, so all week I just told you I was working on N8N, and that was just my code name for taking care of my infant.
You're sure that's not Nathan? I mean, is that like? And also, I got to say that now that I'm looking at section 3.7 N8N, there's, not a lot of detail there. It probably doesn't Google very well. I'm just saying it's very convenient. I'm not I'm just like totally convinced these things exist. That's all I got.
I'm pretty sure N8N is short for New Brunettes.
I do not know if this is like the affirmation pronunciation thing. It's just like, is this a bit?
This is the long con coming to roost for sure.
You were investigating a bunch of these different workflow frameworks. Only some of them made up, some of them real, presumably. And you're kind of coming to Adam, it's kind of interesting what you're saying. Like in retrospect, how could we? I feel kind of the same way about Hubris, the operating system. Like, how could we ever have thought that we would have been able to use something off the shelf? Of course, we need to do our own thing. But it was good. I think it's a good. It's always good to do that investigation because you don't want to walk past something that actually does everything that you need. You really do want to make sure you're doing all of your homework on this.
Absolutely, especially for something that feels like it could be a thing, right? Like it could be that other people have had. Even as we describe instance provisioning, it is not unique, right? Like, and we know, existence proof of Katie's work, right? Like clearly other people have had similar problems. So have they distilled them into solutions that are sufficiently close to what we need?
Yeah. So you were familiar with Katie's work, and I think I'd run across it, but but you got her in. We talked about it. The discussion was great. That was really interesting. One of the questions that we had was, is there a crate, a library, something that we're missing out there that does this? And she was like, no, this is very hard to make general purpose. And Dave, when you were, as we were investigating it, and because it felt like this is the right level of abstraction. Do you want to explain what sagas are a little bit? Because that would probably be helpful.
Sure, I'll do my best, and people can jump in where I've forgotten stuff or whatever. But basically, the way I think of a distributed saga is that you decompose a complex operation into a bunch of these actions. There's also a terminology thing. I'm gonna use our terminology for a second. A bunch of these actions that are individually idempotent and have associated undo actions, and then you build a DAG of these things, a directed acyclic graph. So you have each of these actions be nodes in a graph, and then you have lines between them, which are the dependencies between them, and basically say this thing depends on that other thing. And I'm afraid I have some background noise. And is that a problem?
No, you're good.
No, I think that we would, in the spirit of Oxide Friends, we would ask that the clarinet lesson also kick in there. That's possible. I know the kids are young, but maybe that's
okay. I think
gotta start them early.
I think it's a little quieter here now. So what we ended up building was Steno, which is a framework for this in Rust, where you define your actions and you define the undo actions, and there's traits for these things, and then you can describe the shape of the graph. And Steno's job is to execute it according to the rules of Distributed Saga. So Distributed Saga is basically a bunch of rules that say, about how to execute this thing such that it always converges to either all the actions having completed successfully or all of the undo actions having been run for everything that had been run. And the other way it gets phrased in the talk is that you can sort of think of this like a non-atomic database transaction where you have a bunch of things that you're going to do, and you're going to go all the way to the end, or you're going to undo the whole thing. But the things you're going to do may not be database operations. They may be requests to other services or something like that. How badly did I butcher that explanation?
No, that's great. And I think that what we learned from talking to Katie is that when she'd used this pattern for Halo, they actually hadn't needed to do a bunch of the undo actions. That they were able to fail forward for just the use case that they had. But
that makes sense. Yeah.
Which I think is kind of consistent with our experience. So, and I just think that this is a helpful way to think about the problem in terms of like taking it apart and then allowing us to kind of reason about these pieces and it's slightly smaller granularity in terms of like the action and the undo action.
Totally. And if you squint at it, if you go back to the handwritten code I was describing earlier, where you just like do a bunch of things, and if they fail, you do like go to out. And then you ask, well, what would happen if I crashed at various points? This is basically serializing state for you at each of the points where you might have failed and keeping track of what you have to undo. So I really think of it in terms of decomposing a problem. Like writing a saga is not like whole cloth work. It's like doing whatever you would have done, but taking the pieces and putting them into these small actions so that the framework can keep track of what you have done and what you have to undo.
That's right. I mean, in that regard, it is more of a pattern then, and it's makes sense why there are not a lot of, and maybe there are more now. I mean, because in terms of libraries or crates that implement this, and Steno, I think is. I mean, do you think Steno could be used outside of Omicron?
Definitely, and I think a few people have. We've definitely gotten pull requests from people outside who have at least tried to use it. I don't know how successful it was.
So we took a swing at making something that was general purpose ish.
Yeah. So Steno doesn't know anything about Omicron at all. It's just got these traits around actions and undo actions, and it plugs in certain pieces. Like so, the way the implementation of this thing works is it keeps a log of all the things that it's doing basically before it does them. I mean, it's very simple. There's not magic here, but basically before starting any action, it durably logs that it's about to start the action, and then when it finishes, it durably logs that it finishes, and then it does the same for all the undo actions. And so Steno basically, that's another trait that you implement for that. So our component Nexus incorporates Steno and fills in these traits with our specific actions and with a storage backend that writes these things into CockroachDB so that we know it's strongly consistent, highly available, and all that stuff.
So I don't think I realized that the storage backend is actually orthogonal from Steno. That we actually, if we fill that in on the Nexus side.
That's right. Yeah, and that was, I mean, if nothing else, it was helpful for testing because Steno has these little command line tools you can run that spit the log as just a file of JSON records, and you can literally like delete, you can like truncate the file and then like replay the saga from that point to simulate a crash. And the test suite does that kind of thing too. It was a helpful way to factor the whole thing. To just be like it can be stored however you want.
Right, and so it implements this in-memory store inside of Steno to actually to be able to go test this stuff.
That's right. Yeah.
Yeah, that's great. Okay, so
Dave,
we start.
Question from chat:
Yeah.
How do sagas would you say differ from a workflow? I know workflow is a pretty abstract term.
Yeah, I'm not sure what is meant by workflow.
Yeah, that's right. I think maybe Sagas is a type of workflow or our distillation of what we think of as a workflow. Is that fair?
I think that's right. And one thing I'll say is when I hear workflow, I think of something that is decoupled from the specific workflows that it runs, for lack of a better word. So like, and this is the organizational problem I mentioned earlier. Like there's one service which just knows how to run workflows and like that's what it does. And it's other services that use it might upload some description of what actions it wants to take, and that makes up the workflow. And ours is not really like that. It maybe could be, but it can't be. I mean, right now, it's the way we have incorporated it into the system, that would be pretty hard. But that's by design because it introduces these dependencies, these API dependencies we didn't want to have to deal with. Did that make any sense? Like, it's not as general purpose in that sense. Like, you can't run a Steno server to which you upload sagas and run it, I think.
Yeah.
When I also think that like sagas are a pattern that are coming, and I just dropped a link to this paper in the 80s, 1986, I think. It's coming from databases rather than coming from distributed systems. You're taking this kind of database pattern and applying it to a distributed system. And I think that, I mean, for me, workflow is just a little too abstract as a term. It just means too many different things. Didn't I implement something that we call workflows at Fishworks that is something totally different?
Yeah.
I remember it just feels a little too abstract as a term. And sagas, whether I think it's a great name. I mean, admittedly, but my wife is a literature PhD in Scandinavian studies, so of course I would say this, but I like I think it's not an overloaded term. which I think is actually valuable here.
Yeah. If I can jump in, someone asked a great question in chat that I think clarifies the abstraction a little bit. They said, what happens if you do get the log start but don't get the log for end? Is a half-completed operation able to be rolled back? So the question is, like, this framework has logged the thing saying I started an action and then crashes and comes back up. It doesn't know what happened, right? The framework will execute the action again, and that's why it's critical that the actions be idempotent. So even if it knows for some other reason that the saga has failed and will unwind it, it still has to execute it again so that it can run the undo action in some known state. Because you can't run the undo action for like a half-completed thing. So that's how that gets handled.
And does one's undo action then needs to deal with the fact that this thing has potentially been run twice? Or is it just the expectation is that the actions all have idempotency, so it doesn't actually matter? The fact that the action ran at least once is all you should need to know.
I mean, the hope is that is all you should need to know, but it is true that the action may have run more than once, or partially run more than once, and the undo action does need to work in that case too. And so I don't know how much we want to jump too far ahead, but we did run into problems like this. And a classic case where you run into this is if your action is to insert a record into a database with a primary key, that will work the first time you run it, but the second time you run it, it'll fail because the record already exists. And we've definitely had that bug. And Sean built a really cool test. It's not a framework or a runner, but it's like a helper, I guess, that takes any saga at all and runs it up to every point, and then like we'll replay a particular action. So we basically test running every action more than once. And then there's a bunch of other, like we test inducing a failure and unwinding it, and then running undo actions multiple times. And that thing is pretty generic. I think it can basically take any saga, which is pretty cool.
Yeah, that is cool. Yeah,
it's really cool. No, it's really cool. I mean, it highlights some of the benefit of putting some structure around it, as you've described, Dave. Whereas if we just had a bunch of conditional code that even with manual logging or manual replay or serialization or whatever, the fact that if you express your composite action as a saga, you get all this more or less for free is really neat.
I just want to, just going back very briefly to the discussion of what's the difference between a saga and a workflow, I want to highlight Tef's comment from the chat. And they've written, I just really want this on the podcast. Tef's written, when I hear sagas, I think transaction semantics enforced at the application layer, which, yeah. And when I hear workflow, I hear a DSL that doesn't have a for loop.
That's very good.
Yeah, I just wanted that on the record.
For good reason. That's a very concise way of phrasing it. I think so too. I think that certainly matches my understanding. Dave, is that Adam? That's a pretty good description, I think.
Yeah, that also matches my feeling. I would not have thought to say it so well.
So, Dave, as we're getting into this, so now we're kind of through 2021 into 2022, we're implementing more and more of this control plane using sagas. Where are we finding the wins, and where are we finding some of the challenges?
Yeah, so actually, before we even get there, I want to mention there's two parts of doing this in practice that are really not addressed, at least in the talk. I don't know if there are other places where it's addressed. One is SEC failover. So the SEC is the Saga Execution Coordinator, and it's the thing that, in our case, is running Steno, but it's executing all these actions, right? And at some point, you kind of have to decide, or for availability, you may want to say, what do I do if that thing goes away completely? And we spent a lot of time wrestling with this and ended up basically punting on it because it seemed very hard to extend the model of sagas in the way that you would need for that to be implementable generically. Like, in other words, you want to be able to say, I don't know, that two sagas can't commit the same result of an action, but the problem is same action twice, like two executions of it. But the problem is you've already done the work. So you could have a different model where you have not an undo action, but undo a duplicate action, but it just ended up getting super confusing. And so we ended up punting on that. And that's basically been okay. And we can talk about how that actually works and isn't a problem for us, but that's getting a little off the rails. The other big area is sharing state. So the canonical example of distributed sagas, at least from the talk, is booking a trip. And it's like you book a trip by booking a hotel and a car and a flight. But those don't share any data between them, right? The case that we were describing of instance provisioning, step 3 is we allocated a server, and step 5 is we picked a server. Step 5 is we allocate some resources from it. We need to know what server we picked in step 3. But how do we get that information? If we can't just store it in memory, because we may not have run step 3 in this instance of this process. We may have recovered the saga after a crash, and that information is not in memory anymore. So we basically invented a way to do that, and I don't know how much we want to talk about that, but that was something we had to figure out and bolt on top of it. That wasn't something I think that was certainly in the talk.
Yeah,
I don't know if we
interesting.
want to dive into those or not.
Yeah, I think it is worth diving into, because this is where this is where it gets kind of like thorny, but also interesting, right? In terms of and what were some of the kind of the trade-offs there in terms of that implementation?
I think the big one is like the sort of obvious way you could do this is you give each saga like a bucket of key value pairs that it can just write to. And, each action can basically store whatever it wants, remove key value pairs or whatever. Does that make sense?
Yeah.
But it felt like it introduces a lot of weird questions, like can you see the results of actions that haven't finished yet in subsequent actions that don't depend on them, or even do depend on them? Well, I guess that you can't be running if you do depend on them, but if you don't depend on them. And would the behavior then be non-deterministic based on what order things happen to run in? And it also meant that the undo stuff would have to be very careful about what possible like bucket of state it could get, right? It would be totally it's maybe hard to visualize without understanding the alternative we did, but like you're back at this question of like, how do I manage this arbitrarily complicated key value pair state? Do all the code paths have to be right? And how do I know that I've checked all of them? What we ended up doing is saying the only way to share state is that each action produces a value. That value is immutable. And any action can look up the value produced by any dependent action. Any action on which it depended. Does that make sense?
That's interesting, because and absolutely. And so this was a topic of discussion with Katie in that 2021 conversation about how do actions consume, how do we pass data between different elements of a saga, different actions, and how do I consume kind of a value that a previous action creates? And there was ambiguity there. I mean, she was like, in her case, like she basically hadn't done that, but it would be interesting to think about. So that's ultimately what we came to, is that you get kind of one value out of an action, and then an action that is dependent upon that action can consume that value. Is that right?
That's right. And to be clear, when we say one value, it's any JSON serializable value, so it can be as complicated as you want. It's just that there's one, and it's associated with your action. And to make it concrete, you could imagine, like, again, thinking of like step 3 is we picked a server, step 5 is we allocated resources on that server, which may mean that we inserted some database records with some UUIDs. And the undo action for that needs to take those UUIDs and remove the corresponding allocation from the database. And you can imagine doing this with the bucket of key value pairs, and you can also imagine debugging nasty crashes in that where we expected some key to be there, but it wasn't because of some uncommon and hard to induce sequence of execution where we just didn't happen to set that key or something like that. Whereas this way, it's much simpler to think about. It's like that value is always there because it's produced by the action on completion, and that's implemented by Steno, so it's atomic with respect to the completion of the action. You can't have an action completed and not have its output, is what I mean. And It always has a particular form.
Okay, do you want to go into what the actions are and how they're implemented, and how storing like this data in JSON makes it tricky for us to upgrade and migrate the coordinators?
Yeah. Do we want to jump into that?
Sure.
Is it too early for that?
I don't think so. So what level are you thinking of in terms of the implemented bit, like the Rust interface
we'll
for
just
it.
talk about how like we write our actions in Rust, and the code itself is not stored in the database, right? And so it's just
Right.
installed code that's running. And so how we coordinate that with the actions and the like log that is stored in the database is kind of tricky.
Yeah, that's a really important point because when you think of workflow things, as someone said, it's a DSL without a for loop, right? You're often writing in some other language that, well, whatever. In our case, it's Rust, and you could be in principle doing whatever you want in Rust, although there's sort of limited facilities that you have in the context of an action. But it's arbitrary Rust code, and it's the return value of that function that becomes the result produced by this action. And the downside of this, maybe downside, I guess it depends on how you look at it, is that the serialized state of the Saga is very tightly coupled to the shape of that DAG and the implementations of those functions. In particular, if you imagine yourself being halfway through provisioning an instance, which is again this like many-step process, and then we upgrade the execution coordinator, so we have a new version of the Saga running. You definitely can't just like load that log and match up the values by the names of the nodes and like rerun it where you were and pray for the best, right? Because there may be new actions the way we initially built this, sorry, I should have said this earlier. The way we initially built this, the DAG the DAG was totally static at build time. And it wasn't encoded anywhere, not in the database, not anywhere except by the Rust code that implemented that thing. So if you loaded the log from some previous version, we might try to line up actions and nodes and outputs and stuff like that, but it would not at all necessarily correspond. You may have nodes in the graph that don't have outputs that should, and vice versa, and the whole shape of it might be different. Does that problem
and so just to be clear, this is a problem because we have updated the system while the Saga is running.
That's exactly right. That is the specific problem, or the specific case we're talking about here.
Yeah, you could imagine having like the code, stored as, serialized WASM or something.
We did talk about that at one point.
We did discuss it, and then the Saga log would be stored with the code to run it, and so you could have like different versions of different Sagas running. But like we did not have time to kind of implement that, and that has a lot of problems also in terms of like maybe you want to update the WASM executor. Like how do we even integrate that into the system when we're trying to build like 8 million things?
Well, and it also means like now what is an update? Because by the way, there's some software out there that has stored itself into the database it is the old software now that is going to be running for. I mean, there's just a lot of complexity there. And yet we actually brought this up with Katie. We brought up this idea, this WASM idea. Adam is implying that we may have had some mind altering substances.
Look, everyone has like hacked a bowl with WASM and gotten weird.
Also, this is like, man, it was the fall of 2020. The state was on fire. I mean, it was like we were inhaling all sorts of things. I mean, it was bad news.
It was a weird time.
Yeah. It was a weird time. It was a real weird time. So David, how did you? So it feels like, I mean, just arriving at the. I mean, how do you? First of all, to Andrew's point, like, how do you square this update problem? This is really, really thorny.
I think what we concluded was that these are intrinsically tightly coupled. That is, so you could imagine a world where, like, let's say we'd gone and done the bucket of key value pairs, right? You could imagine building that in such a way that the code can look at the serialized key value pairs of a previous version of itself and figure out, what it should do. Like reconstruct itself in the new version. Like that's conceivable. And like in that sense, this choice made that problem harder, the choice that we made. But I think we just concluded like that's going to be really hard to get right and to test exhaustively.
Right. Oh my God, it's going to be harder to get right. And it's also like, it's in some ways like the worst kind of code because it's like, this is code that will only be executed under these limited conditions that will only exist for a finite period of time. In 5 years, those conditions won't exist, but the code will still exist.
Right. Yeah. And so that path seemed like a mess. And so we basically punted. I mean, you could say we punted, we solved the problem at a different layer, but we basically said, we're not going to do that. We're always going to say that a given version of the software is responsible for finishing or aborting all of the sagas that were created at that version. So if we're going to do a rolling upgrade of our fleet, we're going to quiesce the old versions and let them finish their sagas and wait for them to finish and then remove them. And new sagas are going to be created on the new version. And that means that we can't have a situation in which the log that we have stored in the database is different than the one, or corresponds to a different version than the one that is currently running. It does have one unfortunate downside, though, which is that you can't really fix a bug in a saga in a software update.
Interesting.
And it would require, like, if a saga got stuck, for example.
Right. If you have if the bug in the software is that the saga does not terminate, that's going to be a little bit ugly from an update perspective. But I mean, this is also, there's a degree to which that problem, there is a certain minimum amount of correctness that you require in the previous version of the software, which is always unfortunate, and you want to keep that surface area as tight as possible. But in this case, the only way to win is not to play, to make a war games reference, and that you've got to say, like, sorry, previous sagas have to have completed their execution, and we've got to quiesce the system in that regard.
I think you have an even trickier problem if the bug is in unwinding the saga. It's like, if you want to unwind it to clean it up, like, you can't progress forward and you can't progress backwards, then what does that lead you with? Like, do you have to go in and manually, like, clean things up? Or do you just write, like, maybe you just write a new saga that goes in and cleans up all the old stuff? Like, we've done that for other things. We've written actions that run on startup with a sled agent to, like, migrate over old file formats and clean things up. So I guess that's one way forward.
But I think this does illustrate, I think, some of the challenging constraints that we have that are a little bit unusual. One is that we are shipping this distributed system as a product. So when you have an Oxide rack, this distributed system is running inside of that Oxide rack. And we can't have, Mark Cavage's old term of meat in the loop. We can't have meat which is to say a human being that is actually cleaning this stuff up. We can't have an operational run book that cleans this stuff up. So we do need to be really carefully considering problems like update. That's not something that we can just kind of dismiss to future selves. We really do need to be kind of considering that. I mean, it's hard. It's hard to take it, as Andrew's saying in the chat. It's hard to take a distributed system and actually ship that as a product. But that's part of the constraint that we've got that I think is a little bit different than one might have. If one were operating this as a service, there would be corners we could cut here, because we know that, like, well, if that happens, we're just going to manually clean it up. It's like, well, no, we can't do that.
Yeah, worth noting that there are other pieces of software, not here in this domain, but that we evaluated. And I remember one critique, Brian, you may recall this. Someone said that a piece of software was operated, not shipped. And that was like,
are we deliberately not naming that software? Why are we not naming that?
I don't know. I feel like we didn't need to throw.
I feel that if we asked
particular storage software,
if there was a particular storage software that it was operated and not shipped, what? That's
how many guesses would it take? Yeah,
yeah. It is. Sorry to give it
Spoiler
away.
alert, right?
Spoiler alert. Ceph is very hard to ship as a. I mean, we've got other challenges with Ceph, to be clear, but I think it just, and also in Ceph's defense, it highlights the challenge of this. Of having a distributed system that does not ship with a human being equipped with bash scripts. Right. Which the reality is, like, most distributed systems have a human being with bash scripts somewhere. You dig deep enough, and you'll find it. So all right. So Dave, we've kind of made some of these simplifying assumptions. It does feel like was that a bit of a breakthrough in terms of, like, okay, we're going to have this kind of single value, even if it's a complicated value, that we're going to emit from every action. And it feels like that's you simplified the abstraction in a way that makes it easier to deliver a more robust system. Is that sounding too much?
That felt pretty huge to me. Yeah.
Yeah. And I think it's like one of those things where, it always feels to me like the big breakthroughs are when people realize, like, hey, what if we actually don't solve a bunch of this problem? And we kind of take this, Adam, I always think of what we called the simplifying assumption in dtrace, which was you're kind of, when we were wrestling with a really nasty problem with respect to, I think that was provider interface stability, right? Probe interface
exactly
stability.
Right. Yeah. How do we articulate the stability of every probe? And we're like, well, I got millions of probes. How do we talk about it in millions of different ways? I think it was like basically my first dtrace meeting, and said, well, what if we just do it per provider? And I didn't even understand the tangent that you and Mike then went on, but apparently I had said something smart, so I didn't say anything else the rest of the meeting.
It was very, very helpful, because it can be really helpful when someone it kind of offers up, like, what if we actually like simplify the system in a way that we've kind of implicitly thought is unacceptable, but what if that is actually acceptable, and then that is an acceptable simplification, and then it is the gain that we get. And I think with that particular example is like, oh god, okay, that was obviously a huge gain, and David feels like in this case as well, like, okay, that's such a big win in terms of the way we think about this thing, that it's worth some cost we may give up. And I guess the update example is a more concrete example where, yes, there are going to be problems that we're going to create by doing that, but boy, the simplification just feels like it's more than worth it.
Yeah, that definitely felt that way for me.
Okay, so as we're kind of moving through, so what are some of the kind of the other things that we're finding are where are we kind of finding the edges of this thing, and where are we finding it useful, and where are we finding it challenging?
Yeah, so I kind of did a lot of the early prototype work, and at this point, the control plane really was just a prototype. I don't know that we even had sled agent provisioning at that point. So the instance provision saga was kind of theoretical or simulated or something like that. And I think a lot of other people have done a lot of the work on those sagas, and I'll be interested to hear their experiences, so they can point out all the ways in which this actually turned out to be terrible. The next thing that I got involved in was about a year and a half later, in summer of 2022. It became important for us to make sagas more dynamic and to support what we call sub-sagas, which was that, like I said, when we first shipped this, the Saga DAG was effectively fixed by virtue of the structure of the Rust program. Like, there was no way to change that. And at some point, I mean, we have this problem where when you go use the console, people have used anything, GCP, AWS, or whatever, when you go provision an instance, you can choose, like, okay, I can have n disks, and for each of them, I could create a new one, or I can attach to an existing disk. And if I create a new one, I can say how big it is and what image it is and all this stuff, right? And that's a big, complicated operation on the back end, right? To provision the instance, you may create like a whole bunch of disks. And we already have a disk create saga, and we want to use it in the instance create saga, and we want to have all the properties of sagas, namely, if something fails in the middle of this thing, we undo the whole thing. But it's really not obvious how to do that, because creating a saga in the middle of a saga is not itself an idempotent operation, right? Because if you run that action again, you'll create another saga, which you don't want. You want exactly one saga, having completed the action. And so what we ended up doing, and this is a bunch of work that Andrew and I worked on, like I said, I guess it was like 2 years ago now, to basically allow these DAGs to be dynamic, so we would store the DAG in the database as well, and be able to embed sub-sagas in it, in an existing saga. So in the process of constructing the DAG for the instance create saga, you look at your arguments and you say, well, I'm supposed to create a disk, so I just append a whole sub-saga, which is our disk create sub-saga. And that was like a bunch of work, and I think, there were some interesting tricky bits, but, it basically just worked, and then we started using it. And it was great. that part seemed fine, I think. I don't know, Andrew, that's your take.
Yeah, sorry, Andrew, go ahead.
Yeah, I was gonna say, like, I also think it worked great. Like, I don't know how this, like, that problem kind of appeared, and I hadn't touched Steno, and so I touched this problem so I could work on Steno, essentially. But like, the cool thing that I think you made apparent to me, Dave, was that we talked about passing down data through the nodes of the DAG. And when you have this inner DAG, the outer nodes, like the data in the outer nodes, is not visible to the inner nodes. And the inner nodes, like, once that inner DAG completes, like, its data is not available. Only like its last output node is visible to the outer saga, or to the outer DAG. And so that, like, you get this kind of privacy encapsulation aspect for free. We don't write code and like name, say, DAG1, .key or whatever. It just kind of works. And it's kind of this magical dynamic DAG building thing. But yeah, I don't think we've had any real problems with it.
Andrew, that feels like a huge feature to me, that you have that kind of that sub saga can be a kind of a true abstraction, that you can't have something that's kind of reaching into that sub saga and pulling out some intermediate data.
Yeah, it's one of those things that seems like how else could it possibly work? But like it's a little bit like concluding like the local variables of a function should not shadow the local variables of the functions that called it. And you're like, well, I mean, obviously, right? But like that was definitely something we had to realize about this, and we were like halfway through the implementation and like, wait a minute, if you look up the output of a previous node, can you get a node from the Saga that you're embedded inside of? That would be pretty weird, right? Like you shouldn't really be able to do that, because then you could compose sagas. Then the behavior of the saga could totally change because you composed it inside some other saga because it happens to pick up this other thing.
I think if you look at that PR, I had implemented it differently, which was like a much hackier way, where essentially you do refer to the outer and inner nodes, like there's some namespace that's like explicitly declared, and then you like looked at me and you're like, yeah, this isn't good, and I was like, well, how should we be doing it? Like, and then you fixed it up, and I was like, oh yeah, this is much better. And so yeah, it was a good collaboration.
I appreciate too that you haven't mentioned that code, the Steno executor especially, but most of Steno is like some of the first Rust code I wrote. I mean, Dropshot was before this. This was like a year into Rust, but like there's a lot of not great stuff in there that makes it kind of hard to work on. And Andrew has been kind not to mention it, but I will. It's true. It's a problem.
Well, Andrew's been kind enough to mention it to you. I mean, he just lights me up almost on a daily basis about.
That's true. I send Bryan text messages. I'll have like 2 beers on a Saturday, and just like, hey,
that's right.
Before I hit my 3rd beer, I just want to mention that this code that Dave wrote, I'm really not enthused.
I've had to threaten to block him, honestly, just to cool him off. But so that is a sub sagas are an important breakthrough as we're making this thing really real. And Dave, there's also a really important point that you mentioned that I feel we've used in a couple of other places where you really want to have like one body of code that does this thing, and you want to then use that in lots of other ways. And yes, this is like a variant of not repeating yourself and a bunch of other patterns, but it's been really important for us. I feel that we don't have a bunch of different paths to do these things, and being able to kind of leverage that. Right, exactly. Yeah. So Liza's pointing out, it's like, tell me more about this library thing you seem to be describing. It's like, look, I know it's not a deep thought, but it's an important one. I think it's because I feel it is easy to have accidental repetition of complicated things, not simple things, but things that are like it's just easy for that to creep into a system. Certainly we had that in previous control planes, say.
Yeah, and I think before we did this work, the instance create saga, I mean, you're talking about, for example, not having the instance create saga just like create all the nodes of a disk create saga like in the middle of it or something like that.
Right.
Like you want to actually run the disk create saga. You want that to be a composable thing with parameters and output and all that stuff. And yeah, we did think about it, and it just was like, yeah, that seems like it's going to be way too hard to keep in sync and to keep maintained. If you're basically repeating these long, complicated sequences of actions in a bunch of different places. Yeah. But I mean, we did have some nasty workarounds for a while. Like the fact that it wasn't dynamic meant that if you had like 8 disks, we had like the DAG for creating an instance would have 8 nodes that would go create a disk or whatever, and each of them would check like, am I 0 through 7, and how many disks were actually there, and if I'm I greater than whatever the number actually is, then I just do nothing. Which is like very, very hacky, right? And the dynamics end a lot of that stuff up.
Yeah, you got to be thinking like, all right, there's got to be a better way. This is going to be, and it's always nice when you kind of have, all right, having that better abstraction than being able to go clean up a bunch of that stuff.
Yeah.
Yeah, exactly. Like I think that actually was the problem that got me involved. Was I was reviewing somebody's code and I was really confused at what was going on there, and then to kind of explain that this is our workaround. I was like, oh, well, I'm in between jobs. Let's see what can happen here.
In between tasks inside of Oxide, just to be clear.
Yes.
My heart skips a beat.
I heard each task has a unique job. And then I divide my salary just to account for it.
There you go. Is this a good segue to Eliza and the work that she was picking up in terms of like trying to use this stuff for new purposes?
Yeah, I want to hear Eliza's and James's and Greg's experiences here where I know in many cases the abstraction needed some work. We'll say that.
I actually think that the abstraction didn't need that much work. I think I just had to evolve my understanding of the abstraction. Actually, I think that the abstraction was great because it allowed us to do some like really ghastly things that I'm very proud to talk about.
Oh God, that's like the tagline for Oxide and Friends right there.
Oh, you're gonna
ghastly
love
things
this.
ghastly things that we're proud to talk about. Yeah, go for it.
So honestly, this ended up being kind of one of the first really big projects that I've done in my career at Oxide. And it was really cool because our friend Greg, who is also here on the podcast, at least I hope he still is,
Yeah, I'm still around.
had essentially left behind a very large document that was incredibly detailed and incredibly well written, telling me exactly what I was supposed to go do. And then he had immediately disappeared for paternity leave, which was fun. And then, you know, he comes back and we have to sort of like see how well I've interpreted this sort of ancient writings that he's left
That's right.
behind.
The
And
runes,
like
right.
assess whether I actually understood the commandments that were laid down for me. But the sort of project that we were working on, to give a little bit of background, and Greg, you know, feel free to cut me off at any point in this whole discussion. But so we have, as has previously been mentioned, we have this component in the Oxide control plane that's called Nexus, which is sort of the central component where like all of the actual control plane lives. And Nexus is the thing that's, you know, doing all of these, actually executing all of these sagas, and also serving the like internal and external APIs, and interacting with CockroachDB and doing all of these things. And right now we're sort of dealing with the problem of how are you managing the state of the VM instances that are actually running. And when Greg and I are sort of starting to talk about this stuff, that state is kind of smeared across a bunch of different components in what ends up being a pretty unfortunate way. In particular, there's another component of the Oxide control plane, which has also been previously mentioned on this episode, called the sled agent. And that's exactly what it sounds like. It's the sled agent. It's the control plane's agent that runs on each individual compute sled in the rack and, you know, does things like making sure that the VM instances that you said were supposed to be there are actually there, and so on. And the state of a running instance is at this time, in the talk by Katie, she references a really wonderful paper that uses a phrase that's going to remain stuck in my head for the entire rest of my life, which is feral concurrency control. And I
knew
just
where you
like
were going with
very
that one. Is that
recently
one?
rewatched this.
Yeah, it's so good.
Yeah, and so at the time, there was a great deal of feral concurrency control. In particular, we have, I don't know how much detail it's really worth going into here, Greg. Do you think
I think that
how would you
the way
summarize
that
the problem?
So yeah, I think that the way that we had set it up was we had tried to get into a world where, and by we I mostly mean I'd been working on this problem for a number of months beforehand, but we had kind of gotten to a world where if you had a compute instance and it was running on a particular server, then the server on which it was running and the sled agent for that server were sort of the masters of updating the state of that instance for the rest of the control plane. So you would have your instance and it's starting or it's running or it's rebooting or it's stopping or it's migrating, and you're getting all this stuff from the virtual machine monitor that's telling you, hey, I'm doing this, hey, I'm doing that. And you need to, propagate that up from sled agent to Nexus, which can then, get the appropriate things into the database so that these transitions are visible to the users of these VMs. And that, having the clear ownership is okay, but it starts getting complicated, I think, in a couple of ways. One that we had a lot of trouble with from the concurrency control perspective was if you have one of these VMs and you're trying to live migrate it from
Mm-hmm.
one compute sled to another, and you have this rule that says, well, sleds are the ones that are the masters of instance state while you have a VM running. Well, now you got two of them. You have two of these things running around, and each of them they can't see each other directly in the sense that like your migration destination cannot see the updates that are being pushed by your migration source. And so, properly concluding a migration and updating all of your states so that you were like pointing at the right sled where your VM is running now is doable, but very, very, very finicky, and hard to reason about, and takes a lot of like, here are multiple TLA plus models showing that I think we're going to do the right thing. Like it upholds all the invariants I think I want it to hold. So that's one challenge that we had there. I think the other one that really motivated the work, Eliza, that you're going to talk about here, was what do we do when an instance stops? And there's a lot of cleanup work that has to be done. Also, when it finishes the migration, but when it stops is another big one, where
What
we have
about when it
to.
finishes the migration and stops?
And both of those things, but so there's
You
a
can't
lot
see
of
me
complexity
wiggling
there,
my
but
eyebrows.
generally, like I think that it all kind of comes down. Yeah, that case is one that came up like in Eliza's big PR working on some of this stuff. But the case that you generally have to worry about is one where you have your VM and it's running in one spot and then it's not running in that spot anymore, either because you moved it or because it just stopped. And now you have a bunch of bookkeeping you have to do. You have to say, okay, I don't need to reserve resources on the sled that I came from anymore. I have to tell all the networking components like where this thing is at now so that the right traffic can be routed to the right physical sled, or so we can just like remove the entry for the stopped instance for the routing tables and that kind of thing. And there's a lot of complexity in there because we had prior to this been doing all of this work in the up call from sled agent to Nexus that says, hey, here is my new state. And so we've had bugs of the form, oh yeah, like we started doing this and sled agent decided that it didn't think Nexus was going fast enough. So it timed out, but it really needs to send this update because this is like the only state that we've got. And so, I'm going to send it again. And now I've got two Nexuses that are trying to do these things and they're competing with each other. And just the whole, it was like not a completely, we had bugs there. We patched over them, but it was a very, very difficult system to reason about. And so, like Eliza said, back in, I think, March of this year, I kind of sat down and said, okay, here's what I think we should do instead. We should have more of a model where let's just say, all right, look, the VMMs say that they're doing this, that, and the other. The migrations are in this particular state. Here in Nexus, you can see all of these things because you can do like a big database query that will get you all of the information and in an atomic read from the database's perspective. You go figure it out. You go reconcile all of these things. And then we had to figure out how to execute that reconciliation work safely. And so I wrote all this stuff down, and like Eliza said, I basically finished it, and then my daughter was born, and I disappeared for a while, and that's where Eliza can go ahead and pick the story back up, I think.
Yeah. So Greg had a very, very cool idea, which he had left for me to actually go do. And Greg's very, very cool idea was, so I think it's also worth just noting that right now, at the time that we're like embarking on this project, most of the sagas in the Oxide control plane are initiated as a response to some kind of like user initiated action. Like you say, I want to have a VM. I want my VM to be started. I want to delete my VM that I used to want to have and now I don't want to have anymore, right? And so those are all triggered by like an API endpoint that the user is hitting either through the Oxide CLI or through the web UI or through some code that they've written against our public API. But this is a little bit different because this is something that we want to do sort of mechanically in response to something has actually happened in the real world and we've received some information saying that it's happened. And in particular, what Greg has kind of determined is that sagas let us do something really cool that I think is going to like tie into a theme that I had spent this entire project thinking about, which is that, there's a guy on this call who really hates distributed locking. Andrew, do you want to say that you are the guy who really hates distributed locking?
Andrew, you have something you'd like to say?
Yes, yes, I do hate distributed locking.
Is this some kind of a trick? Because I feel like I'm always the person that's like, no distributed locking, no.
Okay, so there's actually two guys on this call who really hate distributed locking.
Dave and I
then
very
there's
much
also
agree.
me and there's Greg. But we decided that we should have distributed locking. And in particular, Greg has recognized something that I think is really cool that I don't know if anyone else has like really meaningfully like realized you can do thanks to sagas, but maybe they have. But I thought that it was quite neat, which is that, because you have this idea that a failed saga unwinds, you have essentially something that feels a lot like RAII in Rust, right? Where when you acquire a Rust mutex, you get back this guard, this, like, in some sense, real thing that you are holding on your stack, right? And then if you panic and your stack unwinds, you drop that lock. Or if the function call that you are in returns normally, you drop the lock. So there's this kind of like guarantee that by leaving the context in which you have a lock, the lock is released. And with distributed locking, there are a lot of fundamentally the same concerns that you get with not distributed locking, which is that, like, what happens if somebody gets the lock and then they just like die? Or, what if they just like wait a really long time to release the lock and now the lock is just held and I can't do anything that I want to do on the computer? And that's kind of sad. But
Even worse than that, right, Eliza? Like,
Hmm?
you have this situation specifically with distributed locking where you don't have coordinated clocks. And so, like, let's say your lock is based on a Lisa timeout so somebody can determine that it dies. Well, did it actually die? Like, maybe
Right.
the time is different on the remote node that thinks it can claim the lock now, and the other node is still running. Or, like, it just goes to sleep for a little bit and comes back and its clock didn't change at all. And so now you have no lock at all. You just have two nodes like acting on the same resource.
You're actually the one who's been dead, right? Because you might be the one who's on the side of the network partition that's cut off from all of your friends.
Yeah, it's a nightmare.
Right, and part of the challenge is even if you're checking for this, you can always like check the time and then like be off CPU for 10 minutes and then do the thing that you shouldn't do because you can't do it atomically, right?
But so the kind of neat thing about this unwinding of sagas is that you can do something kind of like RAII with your distributed lock. You can have the saga acquire the lock, and when it runs to completion, as part of one of the final actions that it does, it releases the lock. But if the saga fails, it unwinds. And the compensating action, Greg has told me, now we said the word undo a lot earlier on the show, but like Greg has told me that he's decided that undo is actually problematic and we shouldn't call it that anymore.
I think this is just my personal hobby horse. Steno documentation refers to this, to the reverse actions as undo actions. I have taken to calling them compensating actions just as a way of noting that in some cases when you unwind a saga, the post state from your unwind is not the same necessarily as the pre-state before you started running the saga at all. And the sort of trivial example of that is something like a generation number that you're bumping for optimistic concurrency control. But we have other cases where that comes up, where you could imagine, for example, an instance provisioning saga that moves you from your creating state, and then if you set the option, like it tries to start your instance right away, if like the starting bit fails, then like after that, I mean, it's kind of a poor example because do you unwind the entire create? Depending on how you structured it, you may. But you may end up with something where like no, my post state is actually stopped or something like that. I haven't like restored the world to the pristine state that it had before. What I've done is I've restored it to some state that is consistent with the action that the user asked for it not having been taken. So, but I think this is just like I run off and invent different terminology for things like on the regular, and sometimes it gets adopted, sometimes it doesn't. But I think that's all that's meant there. So
Greg, just bring up because of time's arrow, nothing can actually be undone. This is actually undo should be just purged from our lexicon. It's not
And-
possible.
well, I mean,
Wait.
I think the term makes sense. Sorry, Dave. Yeah, Dave is the one I think who added the term, and I think it makes sense in the context that it is much more suggestive of what it is that is actually like going on
Yes.
here. Like we are trying
Yeah.
to get back to something approaching the prior world state. Just that may look a little bit different depending on the specific context of what it was that you were trying to do. I'm sorry, Dave. Did you have more you wanted to add on top of that? I feel like that was your term. The undo.
Oh
the
yeah,
undo term, that is.
totally. Yeah. So I meant to mention this earlier. I kind of alluded to it, but I didn't actually come back to it. That we chose pretty different terminology for a bunch of the distributed sagas things. So if you were familiar with sagas before, you may be very confused by a bunch of the terminology. Like sagas we call actions. Sagas calls requests. And I just basically changed a bunch of these because I thought they were confusing in our context. In particular, like these requests were not actually necessarily HTTP requests or RPCs. In some cases, for us, they were like generate a UUID, and that is like the
Right.
whole action. So I found that confusing. Compensating, undo just felt more evocative, but I can obviously the argument that you're saying it's more compensating than it is undoing is totally fair.
I certainly think that like far more people are going to immediately understand what is meant by undo than compensating. I think that Greg's observation specifically is that, in a world with generation numbers, times arrow is very real. And like even undoing the state changes that you did might mean changing a generation number to a number that it's actually never been before. So it's not really undoing, but maybe. But the point is, this is like actually like a argument over semantics. But the sort of neat thing is that, you can actually have some guarantee that locks are always released reliably in a world where everything is a saga that can unwind and run these compensating actions. And that allows you to have, I hesitate to use the word fearless, but it allows you to have marginally less fearful distributed locking if you are willing to operate under the constraint that a distributed lock that you have created is like never acquired in code that is not part of a saga action. And so we have gone and done that for our instance update saga, which is the thing that is now, rather than having as Greg was describing previously, rather than having the sled agent sort of go, hey, here's some state that I've decided that this instance is in, and turn it into JSON and send it to Nexus, which then just sort of blindly goes and puts it in the database, and then hopes that the sled agent has like incremented the generation number correctly. Instead, we have said, okay, the sled agents are no longer responsible for owning the instance in its state, because its ownership might be kind of smeared across multiple sled agents. And instead of doing that, we're going to have all of the changes to the way that we represent the instance and also the resources that it sort of logically owns, such as, for example, we have provisioning counters of like how many virtual CPUs have you allocated and how many like terabytes of RAM are you consuming and so on and so forth. And you want to be able to like actually have that correspond to the number of like actually properly running VM instances that are physically incarnated, rather than just sort of like going up and never going back down, because then you can't spawn any more instances ever again. And we like, it's very important that those resources be cleaned up. And then separately, we're also tracking the resources on the individual compute sleds, the sort of like physical rather than virtual instances, And it's very important to clean those resources up too. And you don't want to be like adjusting one of those sets of provision encounters without adjusting the other one. And all of this was actually not happening in a Saga. It was just happening in like an API endpoint handler that would just go and like try and do all of those things. But like
it was feral, if you will.
Yes, it was very feral, except with this notion of, well, the sled agent sometimes owns the instance and sometimes it doesn't, and sometimes two sled agents both kind of own the instance, but not really. And sometimes three sled agents own the instance, and sometimes nobody owns the instance, and it's like kind of loose in the cat room. And you can't really go do anything about it because nobody knows who it belongs to, so it can't be stopped. And this would manifest in a bunch of bugs. They would sort of be like, well, I have an instance that like the UI, but it's not running, and it's also not stopped, and nothing is changing its state, and I can't delete it. So that would like often be fixed by like having our colleague Alan go in and manually edit the database records, and that's not very good. So we came up with this scheme where all of these instance state updates would be published, and we sort of removed the notion of having the sled agent own the instance, and instead we only allow it to own the VMM. And we talk a lot in the Oxide control plane about separating the concepts of a VMM and an instance, where an instance is sort of like the thing that the user is actually like thinking about, which is sort of like, I would like to have my virtual machine and I would like it to be somewhere and I want it to exist. And a VMM is sort of like, well, we have this actual like Unix process that represents the virtual machine manager that's actually currently incarnating a particular instance. And we have like separate database tables, separate API objects for these. And in particular, we determined that, okay, the sled agent can just publish the state of the VMM. And when a Nexus sees that the state of a VMM has transitioned in some way that requires the instance, which is like, these are two database tables, that requires the state of the instance to also be transitioned, right? Like perhaps this VMM has shut down and now the instance actually is no longer running. So we have to go back and change that. But before we can go back and change that, we have to release all of these virtual provision encounters, delete some NAT table entries because that instance is no longer actually occupying an IP and so on. And all of these things have to happen. So we've written this Saga that does all of that. And we have introduced locking for each individual instance because we don't want to have, like, of course, the Saga itself is idempotent and we can run the same Saga multiple times and that's totally fine. But what we can't do is run two instance update sagas that are trying to handle different updates. For instance, perhaps you oh God, I can't say for instance when I'm talking about this, can I? That's really bad. But perhaps you have migrated your instance from one sled to another, and you've been like doing the work necessary to update your understanding of the world to reflect the fact that that instance has moved, and then the VMM that it was running on has died.
Yeah.
Right? Like while you were still processing, the migration is finished. Well, there's been another state change, and you can't handle that state change until the previous one is completed because you're going to mess up the previous state change. And so because of that, we've introduced this lock, and because we've now added this lock, we've created a way that the sagas sometimes can't run, which required us to then go and do a bunch of work to make sure that they would always eventually run. And we did that primarily using Nexus is basically composed of two things, which are sagas and background tasks. And the background tasks are just the other sort of part of, somebody mentioned the Kubernetes controllers, and they're kind of like that. They're what you might call in that context reconcilers or reconcilers. Somebody's going to get mad at me. So, Andrew, we actually sort of do that now in the branch that I merged. not to get too inside baseball. But
We
the
should repeat
other,
Andrew's question for the listeners.
yeah, so Andrew asked in chat, I would like a way to make sure the sagas don't even have to run rather than the first node that does the log checks. And we actually did a bunch of work on that. And in particular, we sort of moved before, as part of adding the lock, we did the other sort of thing of moving as much state as possible out of the lock. For instance, we used to, God, I can't keep saying that. I really have to stop saying for instance. We used to have a notion of an instance state, and we would just always give API clients the instance's state. And then we have separate notions of the state of the VMM that incarnates that instance. And we kind of realized that there are some state transitions, like if you are going from stopped to starting to running. When you go from starting to running, the instance record that we have in the database doesn't actually care whether you're starting or running. It just cares, is there a VMM incarnating this instance, or is it non-existent? Similarly, if the VMM reboots, and then it's like, now it's rebooting and then it's running again, the instance record doesn't care about that. It just cares about, do I have a VMM and do I have a foreign key that identifies that VMM? And so we just changed the code that synthesizes these externally visible API and instance states to make that decision based on, well, if the instance has a VMM, we just look at the VMM state, which means that all of those state transitions now mean that you don't have to mess with the thing that exists within the lock, so you do less locking. We also made the compensating action that releases the lock trigger one of these background tasks, which are our sort of reconcilers, that the Nexus background tasks are also completely stateless, and what they do is they read all of the state that they're going to operate on from the database every time they activate, and they're just sort of periodically activated to do some work. And they do this by, they store no state across activations except in the database. And so we have a background task that looks for instances that, may be in a state where we have to go and do something to update them. And then it just does that. And so we can explicitly trigger that whenever we try to get a lock because we know we need to do some work and we can't get the lock, because it's already held, we can trigger that background task and say, okay, well, whenever whomever is done using the lock finishes the update they're doing, there's another one that also needs to be run, so make sure that gets started. And in the event that that trigger also cannot acquire the lock, we also just run this periodically, because so at the end of the day, we have kind of guaranteed that eventually the state update will always be processed. We have a bunch of mechanisms to try and make it happen as quickly as possible, because you don't want to say, hey, I want to delete this instance, and you click delete and you're sitting there looking at the UI and it says it hasn't been leaked, or it hasn't been deleted, but it actually has been deleted. We want it to be as responsive as possible to the actual state change. But failing that, we want it to have happened. And so we have sort of multiple layers of defense of making sure that eventually it happens. And the first one is actually moving as much work outside of the lock as possible.
But still within the Saga.
Well, no, moving as much work. The Saga is doing all of the actual mutations of the state of the instance as stored in the database. And it's doing that, it's contending with the other sagas that might be user initiated, like you want to start a stopped instance, you want to migrate an instance, and so on. Those are also sagas. And the actual sort of state machine that we have represented the various transitions that the instance can go through, is what is sort of providing concurrency control there. And this is very much what the feral concurrency control paper would call feral concurrency control. But I think this is sort of the reason that you might want to have feral concurrency control is that sometimes the application has semantics that sort of inherently lock out certain operations, right? You can't migrate an instance that hasn't been started.
Right.
And so that provides concurrency control between the migrate and start sagas, right? If it's already started, the start saga won't run, and if it is not started, you can't do anything like migrate it. So that state machine actually provides most of the concurrency control. The only place that we need to introduce locking is between multiple state updates that were generated like by something actually happening in the rack. I feel like I'm not actually answering the question that you asked. Oh, which was about moving work out of the lock.
Moving out of the lock.
So no, it's actually that we have just sort of allowed more things to happen without without contending the law. In particular, and this is something that credit for this belongs solely to Greg. We have made it so that start and migrate sagas that fail previously would unwind by like messing with the instance state. And so like when you want to migrate an instance, you find a new sled for it to go to, you find a VMM process on that sled for it to go to, and then you set a foreign key on the instance record that says the target VMM of like where that instance is migrating to. And you do like all of the actual work. You draw the rest of the owl. You actually say, "Hey, move the instance." But like in the database, you are creating this pointer. I am not really by life experience, not really a distributed systems person, or really actually ever a database person until now. So I like think about these things always in the context of like I'm writing like code in one address space. So I'm going to keep calling the foreign keys pointers, and nobody can stop me.
Adam can only try to edit you out. That's the only thing he can try to do.
So you have this, target VMM pointer, and prior to us making this change, what happens when a failed migration attempt unwinds is the saga that's unwinding then goes and like unsets the foreign key that it had previously set, right? And this is something that can race with the instance update saga because it might be handling a succeeded migration, or the migrate saga might have unwound because it actually found that the instance was already migrating and it couldn't start a new one. And so we would have that then go and mess with the instance record again. And Greg's and that would increment the instance state generation, invalidating all of the updates that the update saga has done, and then it would have to unwind and would have to schedule a new version of itself, which would then take the lock again, and you would be having like all of this sort of unnecessary lock contention that would make it take a lot longer for anything that you actually care about to happen. So Greg's crazy shit, as Andrew called it in chat, is that he had realized, and this is where I think why we were having this sort of like bike shed argument about whether they're undue actions or not, is that you can actually have the start saga or the migrate saga unwind by changing the VMM records that they've created to represent the like actual Unix processes of the virtual machine managers that the instance is migrating to or starting on. If you unwind a failed migration saga, you can go find the VMM record that you created and put it in a state that means that the saga that created it has unwound. And then a subsequent migration, which previously would only be allowed to start if the foreign key was null, can instead look at the foreign key, say, oh, there is a target VMM there. I'm going to go check and make sure that target VMM is not actually like just sort of a zombie that was left behind by a previous unwinding migration. And it goes and looks at it and sees, oh, it's actually just left behind by a previous migration unwinding, so I can just clobber it. And so the sort of downside of this is that I had to write like a really gruesome SQL query to handle the fact that it might be null, or it might also be in a state where it is just like okay to clobber, and it was far more gruesome to do that using Diesel. But that works, and that allows you to not do a change that like invalidates the optimistic concurrency control of the generation number on the instance record, but it also allows you to not have to, contend the lock, and it allows the instance update that's running to sort of keep running. And this is where all of this started to feel very familiar to me, because I have no background in distributed systems really, but I do have a background in concurrent data structures and algorithms. I've done some like lock-free data structures, and this feels a lot like that. And so I thought that was like really pleasing. And this is where I went, obviously what we also have to go do is we have to add some kind of GC, right? Because we're now abandoning these these VMMs in a state where, they're not actually being used for anything, but they still have these database records and they might still be occupying some resources. So you need something that goes through and finds everything that's now unlinked, and it just like gets rid of them. And that, of course, naturally made me think of QSBR, even though it isn't really, which is quiescent state-based reclamation, which is where you sort of like explicitly annotate like the times in your program where you're not doing anything, and that's when you can just sort of delete resources that were abandoned previously. And it's not really like that because we don't actually do it in quiescent states, we just do it occasionally. So that diatribe is not really relevant. I don't know why I'm saying this. But yeah.
And then also, how did you? So given that, and because this is always a challenge, certainly when you're having a highly concurrent data structure. So then, how do you test all that to make sure that you've got? Because I mean, you're testing for some pretty gnarly conditions there.
So this is where, honestly, like where I have kept all of my shame. I think Dave discussed previously that we have written these test helpers for sagas that do things like you try and run a saga through to completion, and then at every node in that saga, you run that node twice, or that action twice, so that like sort of tests the like idempotency property. I would very much like to get James talking about his locking scheme shortly, because his locking scheme is actually kind of different from mine, and I think that's really neat. But so we have these test helpers, and those are quite nice. We also have a similar one for unwinding, but they actually don't exercise the potential race conditions that you might have between like multiple events happening that trigger different sagas at the same time. And that's actually not something that we've tested a whole lot, because the complexity of the saga interactions was like not that much previously, and now it's like suddenly ballooned into kind of a whole lot of complexity and like a lot of rules that sort of govern these sort of complex like dance of interactions. And honestly, we did a lot of manual testing, and that's something I don't feel good about. But
it beats the alternative. I mean, in terms of
very much does. And what we did have on our side is that Greg likes TLA Plus so much that he did an entire half of a previous podcast episode about how much he loves TLA Plus. And so Greg had written a lot of TLA Plus models that sort of verified that all of these things, all of these rules that we've written out conceptually should work correctly. And most of the things that had, so he was even able to come up with sort of like, I think these are where the races would be, and you could write a like non-concurrent normal Rust unit test that just sort of simulates the conditions where I think there might be a race, and then we can just sort of go find that, oh, Eliza's code is like actually bad and there's a bug in it, and like it would fail in the race. But the reason that it fails is not because we didn't imagine that there would be a race there, but that instead because like the TLA Plus model had like predicted that there would be a race there, and I had just like typoed something. So that kind of answers the question, but we ended up just doing a lot of manual testing of using our stress testing framework and kind of hammering some of these things.
Well, and the question's being asked in the chat of like, how do AWS and Azure and so on do it? And like, this is just a challenge when you're implementing a control plane, especially
It
for a
very
public
much
cloud.
is.
Yeah, and I can tell you that, and anyone that'll tell you that was at as AWS for a long time, is that there was a lot of like gnarliness that had to be cleaned up manually. Certainly speaking for Joanne, we had a lot of when these things we would have a lot of these kinds of pathologies, and they would get cleaned up manually, and it was really not. It was stuff that was not. You couldn't ship it as a product, and the challenge that we've got, and Liza, I thought it was great that you mentioned just like the accounting issues, which are really important. It's like you kind of want to dismiss the need to account for the resources that a VM is using or an instance is using. It's actually extremely important. And if you have a migration that kind of fails halfway in and then is like stopped, and then that that instance is deleted, it's really important that the accounting ultimately catch up to all that, because it is really awful when the accounting is off and you now have. And I think that that there are the answer, like public clouds have all sorts of problems on this, where they are relying on some MapReduce job to ultimately run and hopefully figure out that the state of the world does not match the state that they think they've got. So these are really, really thorny problems.
Yeah, and there are also problems that, like, the SLED resource leak or the virtual resource leak is something that just gets worse every time it happens, right? And then eventually you just can't start VMs ever again because your control plane believes that all of your CPUs are fully occupied, but they're actually just not.
Totally.
And that's something that, like, if it happens once, it's easy to not even notice that it has happened. But when a system runs unattended by its implementers for a long time, it can end up with the customer's system is now in a state where they just can't start VMs anymore. And maybe when AWS has that problem, they have like a nice little dashboard and they're paying a bunch of people to look at that dashboard and go, oh, we're like actually leaking virtual resources, and just sort of go in and clean it up manually. But you can't really do that when you've sold the product to someone and now it's theirs, and they maybe like don't want your support people looking at their dashboard 24/7.
Well, and very importantly, like the Oxide rack is designed to be air gapped. It's designed to, like, we do not operate them remotely. So it's very important that these things need to be automatic with regard to this stuff. So which on the one hand is hard, yes, as Andrew's kind of mourning the fact that we can't operate them remotely, but it makes for a much thornier problem, but it also makes for a much more robust system, because we had all of the problems that you're talking about and more, Eliza, in previous incarnations, certainly, and then even in this, the kind of the control plane prior to your work, like we had a bunch of feral concurrency that we needed to, James got a great. James, do you want to talk at all about the concrete example that you dropped in, because that's very vivid?
I don't have a lot of experience with the particular, so I dropped Omicron issue 5042 in the chat, where there's 20 steps between these sagas interlacing and running concurrently that lead to this accounting bug, and I just, as an illustration of how hairy these bugs can be, and it's very difficult to say, like, make a unit test for that, or like, because the permutations here are just insane. You really can't account for them. It's what makes something like the stress tool pretty interesting. That was referenced a little earlier.
Yeah, and that's Omicron stress, right, James?
Right.
Yeah.
So I was sorry. I was just gonna say, I had said earlier in the chat, we had decided to launch sagas based on API endpoints and user actions, which perhaps was a mistake, but here we are. The Omicron stress tool will take, for example, like a disk create or a disk delete operation, spawn a arbitrary number of these actors, which they call antagonists, and just hammer our endpoints. So you end up getting a case where, actor 1 called a disk create, actor 2 called a snapshot create, somebody tried to migrate an instance, and then there was a disk delete operation. You end up sort of stressing out these different permutations and interleaving sagas. in a way that really it's kind of frustrating to deal with, but also it's really interesting because you really feel like you have to go in and do this giant post crash investigation and call in the National Saga Safety Board and get everybody together and really figure it out. It's quite subtle. Back to I think what Dave was asking. Steno's great, the framework's great, but this you can really subtly get Saga code wrong. There's no like trait for something being idempotent, or the compensating action can be rerun. Like it's a lot of it is up to us and sort of getting this stuff right.
And Steno gives us a great structure for it, or Sagas gives a great structure for it, but ultimately, like, these problems are really thorny, and it's we've tried to maximize our opportunity for success here. And Eliza, did you need to extend Steno at all for the stuff that you were doing, or was that or you
no, actually
able to merely abuse it?
I was able. So we didn't actually talk about the like most ghastly thing that I like ended up having to do, but I think it's actually like in some ways not that interesting. But Andrew and I talked about potentially making a change to Steno, which is that we had a situation where, because this instance update saga that we've written might handle a variety of fundamentally different state changes, right? It might be doing a state change where an instance is migrated. It might be doing a state change where an instance has stopped and been destroyed and is no longer incarnate. And the work you have to do to handle those state changes is really different. Like in one of them, you actually don't have to delete those virtual provision encounters, and the other one you do because it's there. Similarly, the instance might have migrated out of a already shut down, and so you also want to go and physical resources that VMM embodied, or it might not have finished, and so you like don't want to do that yet, but you do want to update the instance so that it's in place, and so on. And so the Saga DAG that you're building depends on the update you're processing. But, and this is where it gets kind of catch-22, because we have this distributed locking scheme, the Saga needs to be operating on an understanding of the instance that was read within the lock, right? This is sort of a classic problem in concurrent data structures that's also a problem in concurrent multi-process data structures. So that's actually a little bit hairy, because in order to ensure that the lock is always released when a saga fails, you also can only acquire the lock when you're in a saga. But you can't build the DAG of the saga without having the lock.
The lock, yeah.
And this is actually, I think this was Andrew's idea. Where like I had come to him and I'd been like, wait, what the hell am I supposed to do about this? Greg didn't actually tell me what I was supposed to do about this. And I don't really, like, this is my first time writing a saga. I'm 12, and what is this? And so I'd come to Andrew, and he had said, well, we could maybe go, like, mess with Steno pretty drastically to change it to allow you to build a DAG within the saga, but that seems, like, quite complex, and I don't really know how. But instead, he had the idea, what if you just had a saga that starts another saga? Which is what we did. And we added sort of an inherit lock operation where you just sort of do a compare and swap. That, like, if I'm holding the lock now, I give my child the ID that I put in the lock, and then it tries to do a database compare and swap for, like, well, if it's still the parent ID, then I want to put my ID in. Otherwise, I just want to go die.
So this is a sub-saga that you are basically willing.
It's actually not a sub-saga. It's a second saga. The difference is that so like Ixie has commented that database compare and swap that's how I think about it. My background is in working on things where you talk a lot about compare and swap and not as much about like database transactions. So
that's how I think about it too. Actually, I got to tell you, I love the translation layer. So thank you.
Yeah. So what you're actually doing, like, this is not a sub-saga, because a sub-saga is something that to use the, like, Subsaga is sort of a term of art in Steno specifically. Like a lot of this is kind of Steno specific and not Distributed Saga specific. And I just sort of want to make sure that that is like very
Yeah, right. Yeah, that's important. Yeah.
But a subsaga in Steno, as Dave described, is specifically sort of like calling a tree of functions where they can't see your state, so you can call them any number of times. But those are also built in the Saga DAG when it's being constructed before it begins executing. And we use a subsaga actually in well, because we have one for handling a VMM being destroyed, shutting down, because you might want to handle both a migration target and a migration source, both shutting down at the same time. So you might need to do it once or twice.
Right.
And so you might put one or two of those in your DAG. But instead, what we do is we just have a saga, and it has two actions in it. And it's kind of a trampoline, is how you might think of it. And what it does is it locks the instance record. It reads the database state. Then it and that's like one action. And then the second action is to take the database state and construct the DAG of the actual saga that will do the real work, and then start that saga. And then this is actually where I had to write some of the hairiest code in here, because you have to make a decision of whether or not the parent saga needs to unwind and drop the lock, depending on whether the child saga failed before it had inherited the lock or not.
Right.
Which is kind of a complex interaction where we had some bugs that were actually nicely caught by the idempotency tests once I had fixed the fact.
I think this is where
running.
I think the trampoline saga was your idea, actually, Eliza, but like we discussed changing Steno to like how we record the state. So like right now there's a trait in Steno, the SEC store, and that writes to the database. That like writes the database log. So when an action's completed, the log gets updated. And it's kind of done automatically, but because it's a trait, it's built into the sagas themselves. And so there's no way to like take the output of one saga or like even look at like start to run a saga or like proceed with that first state where you look at the lock and then decide not to log anything. And so like part of the problem was you could have a bunch of like you could envision 3 different saga coordinators running, and they're all trying to like run the same saga and they're all trying to take the lock. But if you have these trampoline sagas, they're recording that state in the database. So now you do have this leftover state. And I don't think we still haven't actually done any work to like we've mitigated some of the worst problems with this, but like we still are going to have a bunch of sagas that unwound solely because they couldn't get a lock, right, and record state in the database.
Yeah, we try really hard to not start sagas that are ultimately fated to die, but we are going to still start them sometimes because sometimes multiple state changes happen.
Well, and Dave is mentioning in the chat that and David, do you want to elaborate on what you just said in terms of like the things that are not a fit for sagas?
Yeah, so I think I ran into this with some of the DNS stuff like a year and change ago, where sort of the simple example is that we have this thing in the Oxide system called a silo, which doesn't really matter what it is, but each one gets its own DNS name. And so users create a silo, we have to add a new DNS name to our external DNS servers. People remove a silo, we have to remove the DNS name for it. And it seems on the surface like a great fit for a saga, right? Because you have a bunch of steps that you're doing, and you need to potentially unwind them. But then there's all these weird cases that make it kind of nasty. Like what if you've got like 5 DNS servers and one of them is down, like maybe for a long time? Does that saga just never complete? And what happens if someone else goes and creates a silo in the meantime that adds a new DNS name, and the first saga is trying to propagate an old version of the DNS to the DNS servers or something like that? And what about a DNS server that gets added? It needs to get all of the state from all of the silos that have been created. So for folks familiar with what Kubernetes calls the reconciler pattern, it's a much better fit for this. But I think that was at least not obvious to me at first, and it took some wading into it to to be like, this is actually like a different kind of distributed problem, even though it felt on the surface very similar. And so I think we've been running into more complicated stuff in the last year or two that has been where that's been the better fit. Which is not to say sagas aren't still useful. I think they are still useful for the stuff we've been talking about. But although, we've also mentioned how we've been using RPWs. We call them RPWs for reliable persistent workflows, but it's basically the reconciler pattern.
Yeah. And Eliza we're using RPWs to implement. Right. We're kind of as part of of implementing this entire system. We're finding, and just Andrew, you're saying in the chat that there are things that are sagas are going to be the right fit, and where it makes sense to then to add some of this complexity that Eliza, kind of this knife edge that you're walking of like, okay, how do I make a much more complicated thing, but without actually necessarily like forcing that complexity upon all users of sagas versus having RPWs, reliable workflows, and where do we need those?
Yeah, for me, as somebody coming into Nexus in the last 8 months, and not really seeing this history that Dave is getting at of eventually realize that we also need to have the concept of RPWs. It kind of seems to me that Nexus is basically something that exists in the interaction of sagas and RPW. Right. Totally. It's just those two parts. And then there's also an HTTP API on it, but that's kind of the easy part.
Right. Well, this is great. And Dave, I don't know if there's additional stuff you want to elaborate on there, but I think RPWs have been really important. James dropped RFD 373 into the chat. We made a bunch of RFDs public, by the way, that were formally not. So if you find that there's those linked to an RFD that you want to see public, we'll make it public, which we're trying to get all this stuff out there. But it also allows you to kind of see all of our thinking there around RPWs. We do end up using them. And then obviously a bunch of links in the chat to specific. James dropped in the link to the trampoline saga, Eliza, which is obviously very helpful to kind of see the specific concrete embodiment, because especially if you're new to distributed systems or you're new to this particular problem, this can, I'm sure, feel very abstract, and you can feel like you are just kind of drowning in abstraction. And I know, Eliza, this was definitely one of the challenges that you had ramping up when Greg had kind of, left his runes and then disappeared. It's like, okay, so how do I've got a lot of alien technology that I need to ramp up on here.
Although Greg's runes, I have to say, I wrote a massive comment attempting to explain some of this stuff. And there's also a massive comment in a TLA Plus spec that Greg wrote that is probably mostly still holds, which just went past in the chat. So folks who are actually interested.
Well, and folks, it'll all be in the show notes. For every time we've said it in chat, just check the show notes.
That's right. And this block comment, Eliza, that I think you're about to drop is really, again,
my self-published novel.
Well, I have to. I know we've talked about our hiring process in the past. The nice thing about having a writing intensive hiring process is we've got a very writing intensive team, and I love reading your blog comments. These are these just terrific narratives. And Eliza, I know, and I think you're the same way. I love these writing these comments because it helps me on my own understanding of the problem.
Definitely.
And I kind of, you can, but this was your novella here. Actually, or this actually may just be just a full on novel, honestly.
It's fairly long.
It's definitely Robert Mustaki-esque, another colleague of ours who writes terrific blog comments.
That's very high praise, I have to say.
Well, I very deserved because it is really terrific to read that narrative. And if you had been wondering what makes this problem complicated, why is it so hard? We're just trying to provision a VM. Is it really that complicated? I think hopefully you have your answer. It's it's pretty complicated. A lot of things make it complicated. It is not just dealing with the sunny day case, which is a lot easier. It's dealing with all of the clouds and the storms, and these things fail halfway through. You've got migration in there. You've got the fact that you need to update the software. You've got the fact that this is being shipped as a product and not being operated. And there's a whole bunch of stuff that makes it really thorny and really, Eliza, another thing that I love about this work is it was very much informed by our own experience operating it and with our earliest customers, and really beginning to see like, okay, what are the kind of the patterns of issues that we're having, and how can we kind of address that in a more fundamental way, as opposed to just, chasing the bugs, which you obviously, you want to fix the bugs for sure, but it's like you get to the point where like, no, there's something structurally we need to do here that's deeper, and then that's what you've done here.
Yeah, I kind of think when I picked this work up, I had found like kind of the first layer of what if we papered over some of these bugs with sort of like an incremental layer of fixes that I think Greg
Right.
had sort of gone and done, and then sort of immediately recognized, okay, this is what we're doing, we need to actually solve these problems fundamentally. And so I think I like spent a good chunk of time just sort of deleting a lot of the like hacky fixes, and recognized very quickly, well, if we had continued to go down that path, we would all be very sad. And
Absolutely. And I think that, again, that issue that James dropped in 5042 in the Omicron repo is really, really thorny, complicated issue. Great analysis from Greg. And then, Eliza, it must have been very satisfying to watch Greg close that out as a result of your work, which is
for sure.
Really, I think you are rightfully. This was a ton of work on your part. It was a lot of abstraction to ramp up on, a lot of history to ramp up on. And Dave, are you? How do you feel? Do you feel like your children have kind of come home with facial tattoos here, or how do you feel about the?
I'm trying to figure out if you're talking literally right now. This is the stuff that comes out of really doing it. It's a nice, simple idea in whatever it was, January of 2021, and
January 5th, really 2021.
It's really complicated when you start to do all this stuff, and I think we're still feeling through how we can improve the abstraction. It's all about trying to make it hard to get it wrong, right?
That's right.
And we've been talking about a lot of different ways we have tried to do that, and getting better.
We're getting better. We're getting there. Yeah. And I think that it is, Adam, have we lived up to your expectations for the saga of sagas? Have we?
Absolutely. No, this is delightful. Long time coming. I'm so delighted. This is such a fun conversation. And in fact, you're probably right to hold me off for a year and a half, because we've learned so much about sagas. About what we got right, what we got wrong, what was complicated, some of the trickiest cases. So this has been truly an epic of sagas.
It is an epic of sagas. So everyone, thank you, Dave. Obviously, thank you for your early work on this, and Andrew, Greg, obviously, and then James, and then especially Eliza for all the work that you've done in kind of and motivating this particular discussion with this big body of work that you just got integrated. Congratulations. Very exciting. And future users of the Oxide rack will not know that the pain they never had because of this. So terrific stuff. All right, Adam, we'll have to keep working on that list of the dream list.
Right.
We'll keep working on it. But thank you very much, everybody, and thanks for joining us. We'll see you next time.